Somewhere inside a NOAA supercomputer right now, a number is climbing, slowly, quietly, and almost nobody in the mainstream media is talking about what that number actually means. If you were to walk out to the shores of the Pacific Ocean today and measure the water, you would find a system at peace. Right now, the sea surface temperature anomaly in the Central Pacific is sitting at a mere plus 0.16 degrees Celsius. It is mathematically, statistically, and visibly neutral. To the naked eye, the ocean is asleep. It doesn't look like the beginning of a historic climate event. It doesn't look like a threat, and that is exactly what makes this moment so dangerous. We are currently looking at one of the most unsettling paradoxes in modern meteorology. The surface of the ocean is perfectly quiet, but the world's most advanced predictive models are not. They are pointing toward a massive, systemic reorganization of the Earth's atmosphere. Why are independent, highly sophisticated forecasting systems converging on a devastating super El Niño when the ocean itself barely registers a pulse? What do the machines see that the surface is hiding? Before we decode this, I need to know where our network is stationed tonight. Drop your exact city and country in the comments below. We are building a global monitoring command, and as this system develops, your local observations are going to matter. Let me be absolutely clear. This is not a doomsday prophecy. We do not deal in panic on this channel. This is an investigation, a forensic look at the raw data, the global food supply chains, and the fragile human infrastructure standing in the path of a compounding planetary anomaly. We are going to find out exactly why the data is flashing red. Because if you only look at the surface of the water, you will think there is absolutely nothing to worry about. But the danger isn't on the surface. The danger is underneath. To understand exactly what these supercomputers are warning us about, we have to look at a very specific piece of geographical real estate. It is called the Niño 3.4 Index, and it is the standard measure climate scientists use to define El Niño events. It measures the departure from average sea surface temperatures in a specific corridor of the Central Pacific Ocean. When the temperature anomaly in this box climbs just plus 0.5 degrees Celsius above normal for 5 overlapping months, you officially have an El Niño. When it hits plus 1.5 degrees Celsius, you have a strong El Niño. But when that number crosses plus 2 degrees Celsius, you enter a territory that makes meteorologists extremely uncomfortable. You cross the threshold into what is classified as a super El Niño. In the modern instrumental record, a super El Niño has only been confirmed 3 times: 1982 to 1983, 1997 to 1998, and 2015 to 2016. These were not just weather events, they were global systemic shocks. And right now, in the late spring of 2026, the models are not projecting a modest event. They are not even projecting just a strong event. NOAA's Climate Forecast System version 2, known as CFSV2, is currently showing a central estimate between plus 2.1 degrees Celsius and plus 2.2 degrees Celsius at its peak. Some of the high-end outlier runs within this model are reaching plus 2.5 degrees Celsius to plus 3 degrees Celsius. Now, if you follow climate modeling, you might know that the CFSV2 has a documented tendency to overshoot its El Niño forecasts at long lead times. If it was acting alone, we could simply discount it as a model running a little too hot. But it is not acting alone. The North American Multi-Model Ensemble, the NMME, is a completely separate forecasting system built on entirely different physics and starting conditions. And right now, the NMME is independently converging on the exact same catastrophic range. We are watching independent, physics-based systems arriving at the same terrifying conclusion from completely different starting points. But this brings us right back to our central paradox. If the surface of the ocean is sitting at a harmless plus 0.16 degrees Celsius, where is the energy for this massive anomaly coming from? To find it, we have to look deeper. What you see on the surface of the Pacific Ocean right now is a neutral ocean. What is underneath it is something else entirely. The surface numbers that make the evening news headlines do not tell you what is happening 100 or 200 meters down. In the Western Pacific Warm Pool, a region roughly east of the Philippines, sea surface temperatures have been running between 29 degrees Celsius and 30 degrees Celsius. Over the past few years, powerful trade winds have been acting like a massive pump, physically pushing warm surface water westward. This water piles up, deepens, and gets stored in the subsurface. It acts like a giant thermal battery. Because this water sinks below the mixed layer, it is insulated from the atmosphere above. It doesn't lose its heat. It just sits there, waiting. And right now, the sensors down in the dark, the Argo floats and the TAO mooring arrays are showing that the battery is full, and the anomalies are significantly positive. More importantly, that heat is no longer sitting still. When the trade winds weaken, all of that stored energy begins its journey. It travels eastward through something called an equatorial Kelvin wave. This isn't a crashing wave you surf on. It is a slow, enormous disturbance in the thermocline, the layer where ocean temperatures drop sharply, moving at roughly 2 to 3 meters per second deep underwater. This is the most crucial concept to grasp if you want to understand what is coming. El Niño is not the buildup. El Niño is the release. By the time you see the surface temperatures cross that plus 0.5 degrees Celsius threshold and the media officially announces that El Niño has begun, the decision was already made months earlier. It was made in the subsurface heat content by the physics of Kelvin waves already in transit. The models are not predicting a super El Niño out of thin air. They are predicting it because they can see the thermal energy is already in the water, and it is already moving. But even a super El Niño of this magnitude is not enough to explain the worst climate catastrophe in the modern record. To understand the true threat of 2026, we have to look back to a time when a climate anomaly didn't just alter the weather, it erased tens of millions of people from the Earth. To truly understand the gravity of the configuration assembling in the Pacific right now, we cannot merely look at forecast charts. We must look backward at the worst drought in recorded human history, an event that occurred between 1876 and 1878. This was not a regional catastrophe dressed up in global language. It was a genuinely global climatic disruption that affected every inhabited continent simultaneously, rewriting the survival odds for millions. Imagine the timeline unfolding. The seasonal monsoon rains, the absolute lifeblood of agriculture, simply failed to arrive. In India, the rainfall across large portions of the subcontinent collapsed, with some regions receiving less than 25% of their normal precipitation. At the exact same time, the rainfall systems across China's agricultural heartlands in the Yellow River Basin failed, creating severe drought conditions unseen for centuries. In Brazil's northeastern interior, a brutal 3-year rainfall failure triggered what became known as the Grande Seca, or the Great Drought. Across sub-Saharan Africa, vital rainfall systems that communities depended on collapsed within the exact same unforgiving window. The danger was not just the lack of water, it was the inescapable simultaneity of it all. When one region fails, the world can often compensate. But when multiple breadbaskets fail at once, the system breaks. The human cost of this synchronized failure is almost impossible to comprehend. Historians estimate the death toll from the climate-triggered famines of 1876 to 1879 at somewhere between 30 and 50 million people. In China alone, the incredible famine claimed an estimated 9 to 13 million lives. In Brazil, the drought killed roughly 500,000 people in a region whose total population was only a few million. At a time when the entire global population was approximately 1.4 billion people, this single climatic event effectively erased roughly 2 to 3.5% of humanity. But here is the most crucial piece of this puzzle, the detail that changes everything about how we must view the forecast for 2026. The Pacific El Niño did not kill 50 million people, not by itself. In 2018, a peer-reviewed paper authored by Singh and colleagues, published in the Journal of Climate, did something the mainstream conversation has still not fully absorbed. They used modern climate attribution methods to figure out exactly what caused the 1877 catastrophe. What they found was that the magnitude and global extent of that drought could not be reproduced by Pacific forcing alone. El Niño was just the headline. The actual mechanism of mass mortality was a very specific configuration of 3 separate ocean basins acting together in a synchronized, devastating pattern. The Pacific was the detonator, shifting the Walker circulation and suppressing rainfall across vast swaths of the tropics. But it had help. The Indian Ocean acted as the amplifier. It entered what is known as a positive Indian Ocean dipole, or IOD, where the western Indian Ocean becomes anomalously warm relative to the east. This specific atmospheric reorganization dramatically weakens the moisture flow into the Indian subcontinent, crushing the South Asian monsoon and crippling agricultural output. Finally, the North Atlantic provided the third hand on the scale. Sea surface temperatures in the North Atlantic were anomalously warm, which altered the distribution of moisture in the upper troposphere and changed the large-scale pressure patterns governing rainfall across Africa and the Americas. It was not one ocean acting violently. It was three oceans pushing the global atmospheric circulation in the exact same disastrous direction at the exact same time. The Pacific, the Indian Ocean, and the North Atlantic aligned to force a simultaneous drought across every major agricultural system on the planet. And that is why the real question for 2026 is not simply whether we will get a strong El Niño. The question that should be keeping agricultural planners awake at night is whether these three distinct oceans are beginning to speak the exact same language once again. And this brings us directly to the present moment. The question that should be defining the climate discourse of 2026 is not simply how hot the Pacific will get. The question is whether these three distinct oceans are beginning to speak the exact same language once again. Look at the observational data assembling right now. The Pacific is moving relentlessly toward a strong El Niño. But if we pan across the globe, the other pieces of the SIN configuration are quietly shifting into place. The Indian Ocean is displaying the early structural signatures of a positive Indian Ocean dipole. Meanwhile, the North Atlantic has been boiling in a state of anomalous, record-breaking warmth for 2 consecutive years. Let us be scientifically precise. The alignment is not yet complete. The Indian Ocean dipole has not fully committed to a strongly positive phase, and the Pacific El Niño has not yet peaked. But the directional trend of all three basins is simultaneously pointing toward the exact mechanism that triggered the deadliest climate event in the modern record. In meteorology, there is a specific term for this phenomenon. It is called teleconnection stacking. A teleconnection is how a localized ocean anomaly influences weather patterns thousands of miles away. Think of the climate like an interconnected web of air currents. When the ocean warms, it forces moisture to rise. Physics dictates that whatever goes up must eventually come down. When that air descends elsewhere, it creates high-pressure zones that actively suppress rainfall, baking the earth below. If only the Pacific El Niño is active, it alters these rising and sinking zones, causing droughts in specific regions. If the Indian Ocean dipole turns positive, it independently suppresses the moisture flow necessary for the South Asian monsoon. If the North Atlantic is anomalously warm, it shifts the global distribution of moisture even further. Imagine a single musical instrument playing a note in a room. It creates a sound. But if 3 different instruments play that exact same note at the same time, the acoustic waves combine. They don't just add up, they amplify. They can make the walls vibrate. That is teleconnection stacking. When multiple ocean signals stack their atmospheric responses over the same regions, pushing global circulation in the exact same direction, the resulting climate anomaly is disproportionately massive. But as we look at this atmospheric stacking, we must draw a vital distinction. Drought is an atmospheric pressure. Famine is a system failure. The catastrophic death toll of 1,877 was not written by the climate alone. It was heavily authored by human institutions. The droughts created the physical shock, but the colonial administrations of the Victorian era decided who absorbed it. While millions starved, grain continued to flow out of famine-stricken regions to international markets because the market price was higher elsewhere. The victims died from a lack of purchasing power, rigid market orthodoxy, and deliberate institutional neglect. Today, our world looks fundamentally different. We have global early warning systems, vast international humanitarian networks, and higher agricultural productivity. We do not operate under the brutal colonial extraction policies of the 19th century. Therefore, we cannot assume that a verified triple basin alignment in 2026 would result in 50 million deaths. That is an oversimplification. However, the fact that the modern world is not the Victorian world is not entirely good news. We have traded the vulnerabilities of the 19th century for a completely new set of modern frailties. We have engineered a global food supply chain that is hyper-connected and optimized for extreme economic efficiency. But that relentless pursuit of efficiency has systematically stripped away our buffers. The modern world might not fail in the exact same way as 1877, but as these three oceans begin to hum the same dangerous frequency, our contemporary infrastructure is dangerously primed to fail in entirely new ways. In 1877, the world's food systems were largely regional, connected by slow colonial trade routes. The failure of the Indian monsoon was a localized physical catastrophe that was subsequently amplified into a famine by rigid imperial policy. The 2026 global food system, however, is categorically different. It is a single, deeply integrated global machine operating in continuous real time across every country on Earth. Over the last half-century, we have optimized this system for maximum economic efficiency, dramatically increasing caloric availability and lowering real prices under normal conditions. But this relentless optimization has a terrifying structural consequence: the systematic removal of all our buffers. We now operate on a just-in-time model, which is maximally efficient during periods of stability but maximally fragile under sudden disruption. When multiple agricultural production zones fail simultaneously, the system's ability to absorb the shock simply evaporates. Consider the domino effect. A significantly weakened South Asian monsoon, driven by the compounding forces of El Niño and a positive Indian Ocean dipole, reduces agricultural output in India, the world's largest exporter of rice. To protect its domestic population, the Indian government restricts exports, instantly sending a massive supply shock through global commodity markets. Simultaneously, below normal rainfall hits sub-Saharan Africa and northeastern Brazil. The global market is suddenly forced to absorb simultaneous supply deficits from multiple major production zones at the exact same time. Prices skyrocket. High-income nations simply outbid poorer nations for the remaining grain, acting exactly as Victorian merchants did when they outcompeted starving subsistence farmers. The shock is transmitted globally in hours, but its devastating economic pain is distributed entirely based on purchasing power. If this triple basin alignment fully materializes, the geography of vulnerability will be stark. There are specific regions we must watch intensely over the coming months. South Asia stands on the front line, where the atmospheric forcing of the Pacific and Indian Oceans will stack directly over the lifeblood of its monsoon. For Southeast Asia, including major global rice exporters, this is an immediate threat to crop yields and domestic stability. Sub-Saharan Africa, highly dependent on seasonal rainfall, faces a dual threat of physical drought and unaffordable global grain prices. Northeastern Brazil, the historical epicenter of the Grande Seca, is primed for the same atmospheric suppression. Finally, we must look to the Middle East and North Africa. These regions are heavily dependent on food imports. We have seen this before. The 2010 to 2011 global food price spike, driven by simultaneous but less coordinated climate shocks, directly contributed to the social explosions of the Arab Spring. But before we accept this cascading failure as a certainty, we must pause. There is a very specific reason why climate scientists are holding their breath rather than sounding the final alarm. In atmospheric science, it is known as the spring predictability barrier. Every year, between February and May in the Northern Hemisphere, the ability of our most advanced supercomputers to accurately forecast El Niño drops to its absolute lowest point. During this boreal spring window, the coupling between the tropical Pacific Ocean and the atmosphere above it is at its weakest. The signals the models are trying to read are partially buried under natural atmospheric noise. We are essentially trying to read a message written in pencil against a background of dark ink. We have been humbled by this barrier before. In the spring of 2014, the subsurface Pacific was loaded with heat, and models confidently projected a massive super El Niño. But the atmosphere simply refused to cooperate. The trade winds recovered, The ocean-atmosphere connection failed to materialize, and the extreme event collapsed into a modest anomaly. The 2014 near miss is the cautionary tale that every forecaster carries with them today. The ocean might be loading the gun, but the atmosphere still has to pull the trigger. Therefore, the question is not whether we should blindly trust the models today. The question is, what exact data points over the next 60 to 90 days will prove this nightmare scenario is assembling, and what will prove it is falling apart? If we are heading into the abyss, here is the checklist. We need to see the Niño 3.4 index not just flirt with plus 0.5 degrees Celsius, but aggressively climb toward plus 1.5 degrees Celsius and beyond. We need to see those deep water Kelvin waves continuously delivering their thermal payloads to the eastern Pacific without dissipating. We must watch the trade winds if they collapse, or if intense westerly wind bursts emerge. They are effectively unlocking the cage. Concurrently, the Indian Ocean dipole must definitively cross into a positive phase, and the North Atlantic must refuse to cool down. If all these signals synchronize, this is no longer a model's hallucination. It is a physical reality taking shape. But a scientifically robust warning must also state what would prove it wrong. If the trade winds suddenly roar back to life, trapping that warm water in the west, if the subsurface heat diffuses, if the Indian Ocean remains neutral, then the triple basin alignment shatters. The 2014 scenario prevails, and we breathe a collective sigh of relief. Before we reach the end of this analysis, we have to clear the air. When anomalies of this magnitude appear, the internet inevitably fills the void with conspiracies. Let me state explicitly what this is not. This is not the result of classified geoengineering. The Western Pacific warm pool contains more thermal energy than the entire human civilization has released by burning fossil fuels across the industrial period. There is no secret technology capable of boiling an ocean basin. This is also not driven primarily by the solar maximum. While solar cycles are fascinating, their impact on global temperature is a fraction of a degree, nowhere near the forcing required to generate a super El Niño. And finally, this is not suppressed data. Everything we have discussed today, the CFSV2 outputs, the Argo float readings, the Indian Ocean dipole trajectories, is sitting in publicly accessible databases. The terrifying part is not that the data is being hidden. The terrifying part is that it is right in front of us. But our media ecosystem is too fragmented to stitch these individual anomalies into a single, cohesive picture of a global system under siege. This brings us to a fundamental tension in climate science: the ethics of the warning. If scientists sound the alarm too early and the event fails to materialize, they are accused of fear-mongering. But if they wait until there is absolute certainty, the window for human preparation has already slammed shut. We are currently in that fragile space between early detection and undeniable arrival. This broadcast is not a prophecy of certain doom. It is a map of the fault lines, because the cost of preparing for an event that does not happen is infinitely smaller than the cost of being caught blind by one that does. In 1877, our ancestors had no satellites in orbit. They had no autonomous floats measuring the deep ocean, and no supercomputers running ensemble forecasts. The oceanic configuration assembled in absolute silence, and humanity only understood what had happened after tens of millions of graves had been dug. Today, we have the tools. We are watching the ghost of 1877 attempt to reassemble itself, layer by layer, in real-time data. We have the capacity to see it coming. But as we have learned, seeing the threat and surviving it are two entirely different things. Our modern world, with its tightly wound supply chains, instantaneous market shocks, and lack of resilient buffers, has never been stress-tested by a fully synchronized triple-basin climate shock. History rarely repeats itself exactly, but sometimes the climate creates terrifying, unmistakable rhymes. The oceans are beginning to play a very dark, very familiar chord. The only question left for 2026 is whether the world is finally ready to listen before the music becomes too loud to ignore. The ocean is quiet right now, but the subsurface has already made its decision. As we wait for that decision to finally break the surface, Our role must shift from passive observers to active sentinels. For those of you watching, this is where our global command center truly activates. I need you to monitor the leading indicators in your own backyards. Watch the price of staple grains in your local grocery stores. Pay attention to the subtle shifts in your regional weather patterns, an unexpected and prolonged dry spell, or a sudden, unseasonal deluge. These are the very first microfractures in the global system. If the +2 degrees Celsius threshold is definitively breached and the Indian Ocean dipole locks into a severe positive phase, the window for preparation will close infinitely faster than modern supply chains can adapt. Assess your own buffers now. The modern just-in-time economy will not save you when the shipping containers stop moving. True resilience is now a localized, individual responsibility. Do not rely on fragile systems built for a stable climate that no longer exists. In our next deep dive briefing, we will focus exclusively on the third silent amplifier, the North Atlantic anomaly. We will investigate the weakening currents of the AMOC and decode exactly what happens when a collapsing Gulf Stream collides head-on with a super El Niño. The puzzle is still assembling itself in the dark, and we are among the few who are actively watching the pieces fall into place. Stay vigilant. Keep your eyes firmly on the raw data, not the panic in the headlines. And until next time, remember, nature does not negotiate with our human infrastructure. Be ready. We thought the Pacific was the monster, but what if it is merely the catalyst? As the equatorial currents shift, a ghost is awakening in the North Atlantic. For 2 consecutive years, this basin has burned with an anomalous fever defying historical modeling. But beneath that staggering warmth, a river, larger than any on the surface of the Earth, is slowly grinding to a halt. The Atlantic Meridional Overturning Circulation, the AMOC, is the mechanical heartbeat of our planet's climate. It dictates the vital rainfall over the Amazon and the delicate thermal balance of the Northern Hemisphere. And right now, the data suggests it is hesitating. If a super El Niño forces the atmospheric pressure and a positive Indian Ocean dipole strangles the Asian monsoon, the North Atlantic is the catastrophic wildcard that could shatter the global jet stream entirely. Visual: a high-contrast thermal map of the Atlantic. The bright red surface pulls back, revealing a sluggish dark blue undercurrent. Bold text: the AMOC anomaly. In the coming weeks, as the spring predictability barrier finally falls, the incoming data will either confirm our projections or grant us a fragile reprieve. But the underlying fever remains. The Earth is not simply warming, it is violently reorganizing. Watch the sea, watch the sky, because the quiet is almost over. To grasp what is truly at stake, we must understand that the North Atlantic is not just an ocean, it is the planetary thermostat. The AMOC functions as a colossal, submerged conveyor belt. It pulls warm water from the tropics toward Greenland, releasing immense heat before cooling, sinking, and flowing back south. But sensors anchored deep within the Atlantic basin are transmitting a chilling narrative. The engine is stuttering. For 2 years, the surface has boiled with unprecedented heat. Paradoxically, the deep water return flow shows signs of a historic deceleration. When the AMOC slows, the heat it normally transports northward gets bottlenecked. It pools, stagnates, and violently distorts the global atmospheric currents above it. This is where our teleconnection stacking takes on a catastrophic new dimension. If a super El Niño reorganizes the Pacific and the Indian Ocean chokes the Asian monsoon, a stalled AMOC acts as the final lock on the cage. It warps the polar jet stream, freezing atmospheric waves in place. Weather systems simply stop moving. Heat domes lock over continents for weeks. We are monitoring the real-time friction of a planetary machine struggling to balance its internal energy. The triple basin alignment is the pressure. The AMOC is the fault line. The pieces are on the board. The atmosphere is holding its breath. We will see you in the data. When the grid trips offline, the cascading failure moves faster than any government agency can track. Without power, the municipal water pumps that sustain our urban centers cease to function. The cold storage facilities holding the fragile remnants of our agricultural yield begin to rapidly warm. The just-in-time logistics network, dependent on continuous data streams and electrified distribution hubs, instantly fractures. We spent the last century building a civilization under the assumption that we had conquered nature. We paved the floodplains, air-conditioned the deserts, and optimized our supply chains to the razor's edge of efficiency. We built a machine so complex that we forgot it was entirely dependent on a stable climate baseline that no longer exists. This is the ultimate danger of the 2026 Triple Basin Alignment. It is a brutal stress test of human hubris. The ocean does not care about our political borders or our technological marvels. It operates strictly on thermodynamics, moving heat and moisture with a terrifying, indifferent geometry. The era of passive consumption is over. The era of radical, localized resilience must begin. When the jet stream buckles under the combined pressure of the Pacific and Atlantic anomalies, the consequences cease to be purely meteorological. They become infrastructural. A stalled heat dome does not just raise the ambient temperature, it traps it for weeks. Concrete cities act as massive thermal amplifiers, absorbing radiation by day and refusing to release it at night. This exposes the most fragile connective tissue we have, the electrical grid. Our power infrastructure was engineered for the climate of the 20th century. It assumes predictable peak loads and guaranteed nighttime cooling. But when a jet stream freezes, locking intense heat domes across entire continents, the energy demand spikes exponentially. Simultaneously, power plants struggle to operate because the river water required to cool their systems is already dangerously warm. This is the invisible disaster. It is not a violent storm tearing off roofs. It is a quiet, sweeping blackout across a regional grid that simply overheats and trips offline, plunging millions into the dark exactly when artificial cooling becomes a matter of strict survival. The oceans will dictate the atmospheric pressure, but our outdated substations will dictate the casualties. Radical resilience does not mean building a concrete bunker. That is a Hollywood fantasy. True resilience is the methodical decoupling of your survival needs from the fragile global machine. If the grid cannot survive a stalled heat dome, your home must generate and store its own localized power. If municipal water pumps fail, you must possess the means to purify water independently. If global supply chains freeze, your caloric baseline must be secured by deep pantries, not the just-in-time shelves of a supermarket. We are entering an era where the ultimate currency is self-sufficiency and the data required to anticipate the next shock. This broadcast is an active sentinel protocol. As the trade winds shift and the spring predictability barrier dissolves, we will track the Niño 3.4 index and the AMOC in real time. We cannot stop the Pacific from releasing its heat, but we can refuse to be victims of our own blind spots. The ocean has made its decision. Now, it is time to make yours. The models are not predicting a famine. They are predicting a test. They are telling us that the ocean is loading its thermal weapon. The global basins are shifting, and somewhere, in the next 6 months, we will find out whether the physics cooperates, the Indian Ocean commits, and the triple alignment fully materializes. If it does, the only question that will truly matter is not whether we saw it coming. The raw data clearly shows that we could have. The question will be whether we watched carefully enough to act while there was still a window to make a difference. We must ask if our modern institutions were actually designed to respond to a signal forming right now, visible in public data, and pointing at a devastating threshold. The ocean is quiet today, but the subsurface has already made its decision. The question of what happens when that decision violently breaches the surface across all 3 basins simultaneously, in a world that has never been tested by what they can do together, is a question that the spring of 2026 is just beginning to ask. We are going to find out the answer, whether we are ready for it or not. The only thing we do not know yet is which parts of our world will fail the test first. We have mapped the fault lines, we have exposed the fragile electrical grids and the hyper-optimized supply chains that traded long-term resilience for profit. But there is one final variable in this equation, and it is the only one we have absolute control over: our localized awareness. The most dangerous phase of a compounding disaster is not the moment the grid fails or the shelves empty. It is the period of silent accumulation right before it happens, the days when the data is screaming, but the surface remains deceptively calm. We are in that window right now. The Pacific is actively loading its thermal weapon. The Atlantic is strangling its own currents. The Indian Ocean is quietly preparing to cut the moisture flow to billions. This is exactly why I asked where you are watching from today. A global threat requires a decentralized network of vigilant observers. We cannot rely on delayed institutional reports when food distribution networks begin to fracture. We need real-time intelligence. Watch the staple commodity prices in your region. Monitor the localized anomalies that the evening news dismisses. The 2026 Triple Basin Alignment is no longer a distant theoretical model. It is a physical reality assembling itself in the dark. The spring predictability barrier is falling. The ocean has made its decision. Our watch begins now. When the Triple Basin Alignment reaches its peak, the Earth responds in ways that shatter meteorological boundaries. The immense atmospheric shifts from a super El Niño and a positive Indian Ocean dipole do not merely suppress rainfall, they alter the distribution of water weight across the planet. As trillions of tons of water evaporate from drought-stricken basins and violently shift toward flood zones, the Earth's crust actively registers this staggering transfer of mass. This is where atmospheric chaos collides directly with geological instability. This colossal redistribution of oceanic mass alters the hydrostatic pressure acting upon deep-sea fault lines. The Ring of Fire is no longer an isolated system. It is responding to the atmospheric burden above. Our supercomputers are quietly calculating the probability of sudden crustal displacement and seismic unrest. Modern infrastructure is entirely defenseless against this compounding power. The anomalies we mapped out today are not static. They are actively evolving in the dark. And over the next 90 days, the raw data will either confirm the Triple Basin Alignment or offer us a fragile reprieve. We will be tracking every millimeter of those Kelvin waves, every shift in the AMOC, and every silent fracture in the global supply chain. If you want to stay ahead of the curve and understand the deep forces shaping our immediate future, you need to be part of this network. Subscribe to the channel and ensure your notifications are active. Do not let the mainstream media's silence be your baseline for preparation. We are watching the data so you don't have to navigate the dark alone. Stay vigilant, assess your buffers, and we will see you in the next briefing.